factoring today. We're going to do a factoring review. So chapter P is all about prerequisites, things that you need to know before you came in today. But I'm going to kind of reteach some of them, like factoring. Factoring we did in chapter 5 in Algebra 2 and Honors Algebra 2. It's when you take a quadratic and you try and get it into the binomials. Do you remember that? It's the opposite of FOILing is factoring. Okay, and we're going to have a bunch of different types and ways to factor. So here we go. This is the review right here. 1, 2, and it has all the information. So step number 1 is you want to factor out the GCF, the greatest common factor. That's always your first step no matter what you're doing, okay? When you're factoring, GCF is always factored out first, GCF. Okay, and then for the rest of the polynomial, you're going to look for some special things. Now, if your polynomial has 2 terms, okay? Has 2 terms right there, then you are going to either factor, you're going to look for some special cases. Difference of 2 perfect squares. Do you know your perfect squares? Perfect squares are 4, 9, oops, I should have gone back to pen. 4, 9, 16, 25, ... right? Perfect squares. You're going to look for that when factoring. Now, the sum of 2 cubes and the difference of 2 cubes. These are the hardest ones. Okay? We did this one day in Algebra 2. So are you supposed to remember that? No, probably not. But when you have the sum of 2 perfect cubes, they factor like that every time. That's just a little formula. You may want to memorize that. Okay? And that works for sum or difference. You can have a plus or minus in the middle. Now, with difference of 2 squares, you cannot have a plus in the middle. It does not factor. But with cubes, it's allowed. Do you know any perfect cubes? What's your favorite perfect cube?
27.
Yes, that's mine too. All right, so perfect cubes, 27. 8 is a perfect cube, right? 2 times 2 times 2. 3 times 3 times 3. 4 times 4 times 4. So those are your perfect cubes, okay? All right, then you're going to have 3 terms. Now, if it's a quadratic, you're going to factor into a FOIL problem. I use a thing called the star method. Mr. Bexford, he hates the star method. Yeah, he's not here anymore, so we're all going to use it now. I love the star method, and that's what we're going to do. He liked grouping method, which I used to teach that way, and then I just started teaching star method, and I really like it. He didn't like it because it didn't teach you what was going on behind it. It was just doing a pattern every time, but I'm okay with that. Okay. Now, if it's a 4th degree polynomial, do you see any 4th degree polynomials coming up? Where's a 4th degree polynomial? Ooh, number 6. See how that's to the 4th power? Then you're going to factor it, but you're going to use x squared. You know, like when you start to factor like that, instead of x and x, you're going to do x squared and finish it. Okay? All right. And then 4 terms, we're going to do grouping. Now, if you were in regular Algebra 2 with Miss Callie or myself, we did not do grouping. So that's going to be a new thing for you. Okay? All right, let's get started. So we've got some examples to do. Does it feel good to do math today? Oh, did you know today is a very special day? Have you heard about it yet?
Yeah.
You have? Today is Pythagorean triple day.
Whoa.
I know. So, like, do you know the Pythagorean theorem? Yes, you got it. A, B, and C. So a squared plus b squared equals c squared. Now, it just so happens that sometimes integers work. The one you might know is the 3, 4, 5 triangle. 3 squared plus 4 squared equals 5 squared. That's the one that most people will know. But today is one that works. Do you know what the date is today? 8, 15, 17. 8 squared plus 15 squared equals 17 squared. Cool, huh? So congratulations, you made it to Pythagorean triple day. It's a very, I better call my dad. He'll be very mad if I don't call him and wish him a happy Pythagorean day. He would. Seriously. All right, here we go. So, where are we? Number 1. Here are examples. So, we are going to first start off with the very first thing you do in any factoring problem, which is to factor out the GCF. So, take a look at those 2 terms, and what do they both have in common? A 3. So, a 3 is divisible into both. What else? They can both take out an x squared and a y, just a y. Okay? So, we're going to take our GCF, and we're going to write that on the outside of our binomial. Excuse me. All right, so now let's go ahead and divide out. See, it's the opposite of distributing in, right? Distributing, you multiply the number in. Here, we're dividing the number out. So we're going to divide 3 by 3 is 1. You don't need to write a 1, that's fine. If I take out x squared, I'm left with x. And if I take out a y, I have no more y's. Okay. The next one would be minus 9 divided by 3 is 3. I take out all the x's, so x squared. I take out 1 y, so I'm left with y cubed. And that's it. And that's your answer. And you move on to the next one. Okay? All right, number 2. Ooh, all right, so this one has 2 terms. And you look for a GCF, and this does not have a greatest common factor. So there's no number that can go into 16 and 81. So we're going to go ahead and factor this as the difference of 2 perfect squares. You should recognize this. Oh, perfect squares, yay. And it's the difference, so it's going to work. And here's how the difference of 2 perfect squares work every time. You're going to have a plus and a minus. That way the OI part cancels out, right? Remember that? All right, so what's 16x squared? What's the square root of that? 4x and 4x. And 81, negative 81, would be a positive 9 times a negative 9. Check to see if you can go any farther than that. You cannot. This does not factor. X is just x. It's not x squared. That would be your answer. Does anyone remember this from last year? A little bit? Yeah? Good. We spent a lot of time on factoring. In my class we did. Okay, so take a look at number 3. Look for a GCF. In this case, there is none. But this has 2 terms, and they are both perfect cubes. Now, perfect cubes will probably be the hardest one for you to factor. Just because it's a formula, you kind of have to memorize it. So this is how perfect cubes work. It's always going to be a binomial times a trinomial. And they only factor once. You can never factor the trinomial. You can just factor this, okay? So this is what we do. We take the cube root of x cubed, which is x. If this is plus in the middle, this will be plus, and the middle over here will be minus, the middle term. And then what's the cube root of 27y cubed? 3y. Okay, so that's not the hard part. The hard part's the next part. So I have x plus 3y. Now, I never want to look back at x cubed plus 27y cubed anymore. So for this one, what I'm going to do, there's 3 terms here. The first term is going to be this term squared. This term times itself. X times x, x squared. Okay? The middle term is going to be these 2 multiplied to each other. X times 3y is 3xy. All right, and now the last term is to do this term, this 3y, and multiply it times itself. So that would give you 9y squared. And that's it. Oops. Missed that squared. That's it. Very sloppy. Does yours look better than mine? Probably. Do you remember that at all? Or is that like, that feels brand new, huh? Yeah. No? You remember that one? And then what we did, we set it equal to 0 and we had to solve. Do you remember doing that? And you had to use the quadratic formula and this was a complex number every time? No, not at all. Okay, here we go, number 4. Now, here comes, oopsies, don't do that. Here comes the star method. The star method. For those of you who have never learned the star method, you're gonna fall in love today, seriously. Here we go. So here's what star method is. I can use just a simple cross method or just go ahead and factor if I don't have a number. Like if a is 1, it's really easy to factor. But when they put a number there, it gets more difficult, right? So here's what we do for star method. We make a star. I've heard it called asterisks before, but I can't really say that word, so I call it star method. And for the star method, what we do is we take the top is going to be a times c. So take a, which is 3, and c, which is negative 20, and multiply them together and put it right here, negative 60. The middle term is going to be the b term. I always think b for bottom of it, b for basement, base, whatever. And that's going to be negative 11. Okay? And you've kind of done this before a little bit when you do the grouping and stuff. And then these up top of the star, those are just both going to be the letter A. So in this case, it's 3 and 3. All right, so we set up our star. That's how you set up the star. Yeah?
Oh, never mind. It was loading.
We're good? Was it lagging?
Yeah.
Oh, it does a lot. Is it annoying? Do you hate it?
Yes.
Yeah. Okay. I'm trying this out for the first time. This has not worked, and I should just do it on here, you think? Maybe? We'll see. Okay. All right, so now what we're going to do is we're going to ask ourselves, what times what's negative 60 adds up to negative 11? Can you think of two numbers that multiply to negative 60 and add to negative 11? Yes?
Negative 15 and 4.
Oh, nice. Okay. Negative 15 and positive 4. I'm going to stand over here and watch. Okay, so now what are we going to do? 3 over 4, that's fine. Oh, yeah, look at that. Oh, see? It like finished my... That's weird. Okay, sorry. All right, 3 over 4 is 3/4. That does not reduce. But 3 over negative 15 does reduce. That reduces to 1 over negative 5. 1 over negative 5. Okay? So now what we're going to do is we're going to take our binomials and we're going to write them. So this is how we write them. We have a 1x minus 5 and a 3x plus 4. And that's your answer. Yeah, don't you like it? Star method. It's super easy. That's it. So the number up top of the fraction goes in front of the variable. The number at the bottom is your constant. So 3 would go in front of x and 4 at the end. That's it. Cool, huh? All right, let's start again. Or the next one, number 5. So let's go ahead and factor out the GCF. And the GCF of this one is what? It's not 8, huh? Does 3 go into 18? No, 3 doesn't go into 8. 2. Okay, and x. Yes, good call. So 2x is our GCF. And it's going to show up any second now because I wrote it 4 minutes ago. Or not, you know. Wow, this is really bad, huh? It's still not there. And then we're going, oh my goodness. There it is. Hi. All right, then we're going to do and take out that 2x out of everything. You could probably do that. You don't even need me for this one. So we end up getting a 9x squared minus 12x plus 4. Okay, now you may recognize that. That's one of our special cases. Do you see inside of the polynomial, inside of the trinomial there, that there's a perfect square is the first term and a perfect square is the last term? That's called a perfect square trinomial. Okay, and those are special because those will factor as one entire binomial squared. Usually. Sometimes they don't. I like to put those on the test, the ones that don't, that look like they do. I'm so mean. All right, so 9x squared is 3x. And the square root of 4 is 2. And the middle term would be negative. Okay, if you ever forget that, you can use grouping if that's what you've done in the past. You could also use the star method on that one. You can. Okay, the star method would totally work on that one. Should we do the star method on that one, or you're good? You're good? You like shortcuts, right? I like shortcuts. Huh. Okay, now number 6. Number 6 was one of those that it's a 4th degree polynomial, but we're going to factor it just like we would just a regular old quadratic. We're going to write our 2 binomials there. But instead of x and x, we're going to write x squared and x squared. And then we go, all right, what times what is 2 adds up to negative 3? That's a tough one. What times what is 2 adds up to negative 3? Yeah, there you go. Negative 2 and negative 1. Are we done? Say no, say no, say no. Are we done? Say no. No, thank you. We are not done. Do you know why, though? Or you just because I told you? This one's done. The first one, this one, that one's done. This is just x squared minus 2. You can't go any farther. But guess what? 1 is a perfect square. It's a perfect square. It's a perfect cube. It's a perfect. So what times what is negative 1? We would write x plus 1 and x minus 1. So sometimes when you think you're done, there's still a little bit more to do. So that one right there would probably be worth 3 points on a quiz. And if you got to the second part but didn't go to the third, you might get like 1.5 marked off because you didn't do like half the problem. Okay, so you get partial credit, but you gotta do the whole thing. All right, 2 more. Also, here's the thing. I drink a lot of coffee, like a lot. Like, I think, well, I didn't go over there during break because there was, you know, the free food I had to go and run to get. But I like to drink a lot of coffee. So if I go super fast, say, oh, Price, slow down. All right. So if I'm ever, you know, you don't understand something, please ask. I will never make you feel dumb. I won't. Because you know what? Here's the thing. I was not, you know, a math genius. I wasn't. I didn't really like math all that much when I was your age. I took geometry and I hated it. Anybody hate geometry? Oh, the proofs and all the formulas. I just hated it. So I thought I was bad at math, right? And then my dad was a math teacher. He taught at Wilson High School. Then he taught here for a little while. And I just didn't like it. I went to college. I was an English major. That's how much I hated math. I was going to show my dad that I'm not going to be a math teacher. But then I took calculus and I loved it. See, you never really know. And then you take classes and you're like, and then they spark your interest. Yeah, calculus was great. Anyways, so I never want you to feel stupid because I struggled through some of my classes, especially in college. When I took a whole semester on proofs, it was like, I don't know what's going on. You know, some classes I got a C in. Don't tell my administrators. But yeah, so if you ever need help, let me know. Even though this is an honors advanced math class, you may think everyone around you understands it. They don't, okay? And even if they do, so what? That's not you. You ask me, okay? All right, so let's look at number 7. How many terms does this one have? 4. Now go up to the info that I gave you. With 4 terms, use grouping. Grouping, right? We're going to take things and group them together. Do you remember this? Algebra 2 kids are saying no. And you shouldn't remember this because you didn't learn it, okay? But honors algebra 2 kids, you did. But we don't remember it anyways, right? No, okay, that's fine. All right, so grouping, what we're going to do is we're going to split this polynomial in half. And I like to draw a little dash line right there. And then what I'm going to do is I'm going to focus on the first 2 terms, and I'm going to factor out just their GCF. So what do they have in common? 2 x's, yes. So let's factor out an x squared. And we're left with x plus 5. All right, so the second half, we are going to factor out a negative 5. And that seems kind of weird for some. But you want to factor out a negative 5. It'll show up any day now. There it is. And we factor that out, and we're left with x plus 5. Now right here, bless you, is the point where you say, whoa, those are the same polynomial, x plus 5 and x plus 5. That is not a coincidence. It will happen that way every time. If not, then you can't factor it by grouping, okay? So now we're going to take this entire polynomial, and we're going to factor the x plus 5, which is the same. Do you see this? This is one term. This is another term. And we're factoring out the x plus 5 to the front. We factor that out, x plus 5. And what we're left with is from this term, the first term, we're left with x squared. And the second term, let me erase some of that. We're left with minus 5. Okay? Some of you guys, yeah, grouping, because that was part of your, like the star method that we did. You did that. And then you look to see if there's difference of 2 perfect squares. Is 5 a perfect square? No, it's a nice number, but it's not perfect. So that would be our answer. That's fun. I got to clean that up. That's going to bother me. Okay, whatever. All right, next one. Last one. All right, again with the 4 terms. Again with the grouping. Let's do it. What is that? Oh, I'm on highlighter. See, this is the thing. I'm going to record myself, and I'm going to watch it later and feel like it's like the biggest idiot ever. And then I'm going to like make stupid jokes, like asymptotes and stuff. And anyways, all right. So here we go. Grouping. So factor out the first 2. We can factor out an x cubed. And we're left with x plus 2. All right, from the second 2, x plus 2. Yes, negative 1. Factor out a negative 1. And then we're also left with x plus 2 again. Yay, and that's what we want. And so we're going to take the x plus 2 and we're going to factor it out of both terms. We have this term and we have that term, and they both share an x plus 2. So I factor out the x plus 2 all the way to the front. And what I'm left with is, I'm left with an x cubed and a minus 1. Are we done? Sam, say no again. No, good. All right, we're not done. Now, anybody know why? Perfect cube, yes. We have a perfect cube there. Okay, x plus 2 is done. That's good. But this x cubed minus 1 is the difference of perfect cubes. So it's going to be a binomial times a trinomial. Now, the middle term is minus. Here's a good way to do this. Middle term is minus. You're going to have a minus in the binomial, but a plus for the middle term in the trinomial. Okay? The cube root of x cubed is x, and the cube root of 1 is 1. Now that's when you do not look back, okay? You're going to look at this binomial right here, and you're going to take the first term and you're going to square the x. You're going to multiply the 2 together for the middle term, so that would be 1x or just x. And then you're going to square the last term, which would be positive 1. That should be a plus x and a plus 1 at the end. It's very delayed. There it is. Yeah?
So you just ignore those signs?
You do. Yeah, you put the signs in first and you ignore the signs. Yeah, because when you're doing x times negative 1, you don't want to put a negative 1x in the middle there. Yeah, that's a good point. Okay, does this feel like review? Pretty much, yeah? All right, so let me ask you something. Oh, I'm done, so I